and liftoff.
Well, that was awkward. Well, I'd like to welcome everybody back. Welcome everybody back to the third day of NewSpace 2015. Glad to have you all. I hope the conference thus far has been useful for everyone. As I think I mentioned on the first day, I assisted run NewSpace 1, and it's just spectacular to see how far the event and the organization and, let's be honest, the industry has come in that time. So, I guess I just hope that this event is proving to be everything everyone hoped it could be. So, I guess where I was starting there is that things have changed quite a bit over time, and they've changed quite a bit within this organization from just a few people with a vision to a much larger, really executing and making sure that we deliver the right event and the right things to move the industry along. And for those of you who follow the organization closely, you know that there have been a whole bunch of internal transitions this year as well. And before I introduce Hannah Kerner to bring up our first speaker of the day, I have one announcement that I wanted to throw out, and it's something that I am beyond excited about, and I'm excited to tell all of you. So this conference, in my view, and I hope all of your views, has been easily the best NewSpace conference we've ever had. And the leadership behind that conference, also in my view, and this is speaking as someone who has been a leader of a NewSpace conference, is the best leadership we've ever had. And having watched that record of performance and knowing that we had an absence that some of you may be aware of, I have the privilege to announce that the new executive director and the outward-facing person for this organization, the person who you're going to be dealing with on a day-to-day basis, if you have the misfortune to deal with me, that's another problem, but the day-to-day face of this organization and our new executive director is going to be the person who also happens to be our conference chair, Hannah Kerner. So without anything else, I'll let Hannah introduce our next speaker, but please feel free to congratulate her as you work through the day here. Thanks so much.
Thanks, everybody. Thank you, Jeff. I want to take this time to give a round of applause to the conference team, there are about 39 people additionally to me that made this happen and worked for the past 11 months to hopefully make this look like magic to y'all. This team has blown my mind and hopefully yours, and they've done it 100% as volunteers. So please give them a round of applause, and me. Really quickly, some housekeeping before we get started. There's one gala ticket left, so that's effectively 0. So we are sold out of the gala tonight. Registration will close at 3:30 p.m. So if you want to pick up your gala ticket before that closes, you can, or you can pick it up at the door. We're going to open our morning session with someone with an immense amount of experience and responsibility in the space industry. Debra Facktor Lepore is the Vice President and General Manager of Strategic Operations for Ball Aerospace. She is responsible for increasing Ball Aerospace's profile in the market and facilitating collaboration across the company. She's the company's senior executive in the Washington, D.C. area and leads the Washington operations, communications, and strategic development. She's the former chairwoman of the board of Women in Aerospace. Please welcome Debra Facktor Lepore.
Thanks, Hannah, and congratulations on taking on this new leadership role for the Space Frontier Foundation. It's, I know, a great passion of everybody here in the room to be engaged in NewSpace, and particularly for me, it's a lot of fun because this is my first time coming back to the conference with my Ball Aerospace hat. I've spoken numerous times in different past lives with entrepreneurial launch startups, and kind of feels like coming home in a way, and also seeing the new generation who is here and the students of NewSpace who are continuing that passion forward. So maybe the best thing about this year's conference is that it is caught the attention of the so-called old space. And the many institutions, investors, customers who have had a generation of ways of how we do business and are realizing, wow, things can change, and they are changing, and what do we do about it? And maybe best of all is the fact that consumers are recognizing the value of space and the difference it makes in our everyday lives. So what I'd like to share with you today is a little bit about characteristics of NewSpace and bring it to you from the perspective, kind of my lens, which has been as an entrepreneur over the years, but also what Ball Aerospace is doing, because you might not think of us about NewSpace. And at the end, I'd love your thoughts and ideas for Q&A, and I'll be here throughout the day and this evening, and I look forward to engaging with you. So some of you may say, well, how'd you get here? Like, why are you here? So, I went into aerospace because I wanted to do things that had never been done before. And when the space shuttle first flew, I thought, that is really cool. And growing up in Detroit area and around the auto industry, everything was about cars. I thought that was kind of boring. But clearly I was influenced by transportation and energy since I went to work on launch vehicles and rocket engines. I deliberately chose things in my career that would enable me to do things that had never been done before, whether that was working with the former Soviet Union, who had been our enemy. They were now going to be our friends, bring them into the International Space Station, we'll look at developing or enabling the use of Russian rocket engines in U.S. launch vehicles, a familiar topic today. Raising over $600 million in private capital for Kistler Aerospace, which was going to be the first private commercial reusable launch vehicle to enable the business plans of all the low Earth orbit telecommunication constellations, another thing that sounds familiar today. And then joining forces with DARPA and the Air Force when I was president of Air Launch, which was to transform how we get access to space, and particularly through operationally responsive launch using a rocket deployed from a C-17 cargo airplane. So you might think that a lot of these ventures were about the technology and the platform, but really they weren't. They're really about how to change the way we do business in space. How do we get access to space? What kind of mechanisms? How can we change up the way we contract for things? How can we take a technology that was used in the Cold War and transform it into something that enables CubeSats, for example, to launch? And a big part of that is influence, convincing people to do things that they hadn't done before and that they didn't know could happen. So today I think we're there. I think NewSpace is open for business. It's extremely dynamic. There's rapid changes in technology, in architectures, in business models, in the expectations of how we use data and what it means. How do we link together? There was a time when people still today I think don't realize how the tools come to us from space. Whether you are planning today to look at your, I'm sure you looked at your smartphone today and said, well, which way do I drive? Where's the traffic? Do I bring my umbrella to San Jose or not? All that comes from space. We know that, but not everybody else does. And I think this transformation in NewSpace today is bringing that back down to the consumer, which is really what it's all about. So why did I come to Ball? How did I get to Ball? Kind of interesting. When Air Launch closed, I did some research with Stevens Institute of Technology and the Department of Defense, and on some research that was inspired by one of the reasons why Air Launch failed. There were several reasons why it failed, but one of them was this disconnect in systems engineering. We had DARPA and the Air Force as our customers, and the Air Force would say, you, DARPA and Air Launch, you don't do systems engineering. And we said, well, yes, we do, just not your way. So how do you bridge that gap? And that's a gap even today as we talk about new things in space and linking them with traditional ways, but also just the expectations of the precision, the accuracy, the timing, the quality, the reliability of data that we make decisions on, and how you get that. So the struggle between being entrepreneurial and streamlined and testing and learning as you go that DARPA used, and the very deliberate, methodical approach that the Air Force used, was a problem. So I actually did research on that, and of examining rapid innovation organizations, particularly on the defense side, because there's a lot of rapid capability about getting technology and new things into the hands of the user, and in particular, into the hands of the warfighter. So that research, it's a long story, but it led me in a roundabout way to Ball, because I observed that at Ball was practicing many of the concepts that we observed in the research. And our motto of agility to innovate, strength to deliver was kind of it. Agility to innovate is that entrepreneurial side, and the strength to deliver is the capability to have the most precise data that we use for weather or in our intelligence community, and it works. So I thought, wow, well, Ball's exactly doing that in the commercial side. So we're not a big prime, and we're not a startup. So we're kind of in between. And that sweet spot has really enabled us to bring some of these unique solutions, smart people who know how to solve tough problems, apply them in very different ways, and also come from backgrounds of understanding some of the science that goes into the sensors. There's many of you probably watched TED. One of the most popular talks from TED a couple of years ago by Simon Sinek argued that successful companies start with why they do what they do, and then look at how. And some of the others who are not so successful just look at the what. So our why at Ball comes a lot from the entrepreneurial heritage. In 1880, 5 Ball brothers did a merger and acquisition, kind of, but they borrowed some money from their uncle and bought what was called the Wooden Jacket Can Company. And they started making cans to keep paint and kerosene, and that evolved into glass. Many of you know the glass jars that say Ball, those famous mason jars. Maybe your grandparents use them, or you see them in an antique shop, or they're becoming in vogue again, and restaurants use them for drinking glasses. This is transformation. The company then grew into considering itself as a packaging company. As the market changed, Ball changed and started thinking differently about, well, it's really not about the glass, it's about what goes in it. And sold the glass company in the late 90s and really transformed into a packaging company. You might not know, we make 65 billion recyclable aluminum and steel cans a year. So all those drinking cans that you see out there, Trivial Pursuit kind of question. So when you look at your Coke, Diet Coke, multiple craft beers, Sam Adams, any Miller Coors beer, look by the UPC symbol and you can check the brand of who made the can. And if it's a Ball can, it'll say Ball. It's like this big, but it's that same logo. And then you say, well, how'd you get from jars to the stars? There's a book. You can read it. In fact, there'll be a book review, I think, coming out in Quest magazine that one of the Air and Space Museum curators wrote when I mentioned this book to him. But it's this story about innovation. And one of the sons of the original Ball brothers founded Ball Aerospace. It will be 60 years, in 1956, in Boulder, Colorado, when he had a big warehouse from a company that he had bought that failed, and met up with some faculty and students from the University of Colorado Boulder who were working in the early days of the space program, and that was the company's first R&D arm. For 70-some years, they'd never done R&D, and then they did, and became a passion. They became, it was very patriotic, and Ball, from the very beginning, has been doing a lot of innovative firsts in the space world. Some of those innovative firsts are actually in the news today. Pluto. So how many of you know that Ball's camera, the Ralph imager, is responsible for the wonderful precision and color images that we are seeing from Pluto? Yay, people know. Excellent. We are so excited. So can you imagine, a funny story, talking about data, a lot of the small LEO sats, we're talking about we need data. It's persistence. We're seeing, full motion video constantly over something and getting that data, doing something with now, and that demand is so high. I was out at APL this week for the flyby, and can you imagine the scientists who have been waiting 9 years to get their data? So it's data analytics. It's about what's coming from space. And it's probably pretty rapid now because they're trying to do everything with it. But the wait time for that, you're just putting in the context of the different perspective of how data is applied. So our camera, coming back to that, so you think, well, this mission costs a fortune, the technology process costs a fortune. Well, actually not. It had a lot of budget issues early on. Nobody wanted to do this mission. So we helped contribute to that by saying, well, we can do low cost, high reliability. We built it in 22 months. We came in under the mass and the power constraints. It uses only 7 watts of electricity, just as an example. That camera only weighs 23 pounds. So that little tiny thing is giving all these fabulous images, extremely clever technology. And by the way, it's all made out of aluminum because you couldn't use other materials because of the temperature changes and taking 9 years to fly through many different space environments. But in the end, we don't know how it was made. We don't know how much it cost. We don't know that it was really rapid. All we know is that it's delivering really cool data. And on the way, by the way, if you're flying to Pluto, you might as well take some pictures of Jupiter while you're at it. So these pictures of Jupiter and the moon, Io, was also taken by that same camera and is now on its way toward Neptune through the Kuiper belt. So coming back down to Earth, how do you take technology and thinking about data and turning it around? So for those 9 years, we weren't doing anything. We weren't doing nothing, double negative, either. And we took that same technology from Pluto and applied that in a commercial way. Many of you know we've partnered with Digital Globe since the very beginning with the Earthwatch company that we set up, and we put Digital Globe and built all the spacecraft. This is taken from Worldview 3, which launched a year ago, which is delivering the highest resolution commercial imagery out there. And the technology from one of those imagers, and Ball did the entire system with Digital Globe and a couple other partners, took those pictures, and that's amazing. So you think about commercial fixed price contracting, another key of NewSpace, and an example also of transforming technology from Pluto all the way down to taking pictures on the Earth. So remember I mentioned about this gap between innovation and the real world. Well, I want to give an example because we all know that NewSpace is all about being an innovator and a disruptor and why we're in the business. Our weather program is a great example of that at Ball. So some of you may remember there was a program for the nation's weather infrastructure that was collaboration across all of government with Defense and NASA and NOAA. It's called MPOS. Long story, it had a lot of problems and it was canceled. Ball was building the preparatory spacecraft that was to test out a lot of technologies that were going to be applied later in the program. So it was R&D, it was kind of innovative, you could take a lot more risk, you could take some, do some more investigation of what might work in the system. But NPOS was canceled. Now all of a sudden, the one who's supposed to do the R&D and kind of test things out, it's the equivalent of being in the, we just had the All-Star game in Major League Baseball this week. It's like being called up from the major leagues, like, oh, you're playing in the World Series tomorrow. And you think, well, what is that? I'm in the, I've done some work maybe in the Canadian League or in the European League, but what is this? I have to be on stage now. Like, yep, you're it. So that transformation from being entrepreneurial and testing and to be part of our operational program with weather, real stuff. We're making decisions for where aircraft go, where natural disasters are, in our warfighters of where they're going. This is really critical stuff. So we had to do that, and we did. That spacecraft and system, which was going to be just a practice run, is the spacecraft today that is the only one delivering polar weather data in the U.S. system. And one of the first things that it did is, because of that spacecraft, detected that Hurricane Sandy in 2012 would take a left turn and go toward New York City. Now, I happened to live in Hoboken at the time, so that flooded picture of the taxi terminal, it became a very famous photo at the time. And it's so funny because I was negotiating with Ball to come to Ball. And I was supposed to have a phone call to kind of confirm some of the details, and nobody could reach me. So for a couple days, we had no phones, we had no power, we had no nothing. So it was funny later because they thought I lost interest. Well, she doesn't want to talk to us, we can't reach her. And finally, I texted a picture of the National Guard driving by my house on campus at Stevens. Like, this is why I can't call you. Give me another couple of days and we'll figure it out. But what we learned a lot from that is how important that weather system is. And we have the Joint Polar Satellite System 1 right now in 4 of the 5 instruments are getting ready for launch to help contribute to that constellation. So the other point about space mattering and getting data is just looking at land imaging as well. Here's an example, another flood. I didn't intend to have just, maybe it's because of the California drought here, then talking about water seems interesting. But this is something where another example of innovation happening early. Ball's been involved in the Landsat program, and this imager that we built, which is extremely high tech, was so good that the government started using that data for live relief when there were a lot of floods in Colorado and in 2013. And the spacecraft wasn't even ready. It wasn't even all checked out on orbit. Like, looks good, we need it, we're going to go with it. So another example of being extremely responsive in the right time and knowing that you put in some of the innovation up front. So I'm just going to flip through a couple ideas about some of the characteristics of NewSpace and how you might see those at Ball. So one example is hosted payloads, using that for tech demo and early. We actually have a propulsion program called Green Propellant, changing out hydrazine. And this Green Propellant infusion mission is going to fly as it's really a hosted payload on our own spacecraft, on somebody else's, on the ESPA ring, on somebody else's mission. So that's a lot of partners that you need. And that's to test out a technology, see if it's going to work. And if it does, then we could fly that propulsion and incorporate it into our small sat space test program standard interface vehicle that we developed for the Air Force on Operation Responsive Space. Say, well, change up the propulsion. And now we've really actually helped do multiple things in space, not only enable a cheaper way of getting there and a safer way, but think about all of the contributions for sustainability and better for the environment when we can make a change in how we do space operations. Another example, and this is a good, this one has several, hosted payloads, but also collaboration. NewSpace, I think, you can't do it alone, and nobody has all the money to do everything themselves. We have two customers, NASA and the South Koreans, who both want some environmental monitoring, and they want data to help evaluate the environment. And in South Korea, they have such horrible pollution. They're trying to figure out what to do with it. We had there was a news conference, and the South Koreans came. They came to Boulder to talk about us, and they flashed to one of the cities, and it's in Korean, so you have no idea what they're saying. But you didn't have to know what they were saying because it was so smoggy you couldn't see anything. People are wearing a face mask to try to breathe, and you say, well, this is a real issue. So the two of them are like sister programs. You do this, we'll do that. You learn, we'll learn from you. Tempo is going to be, it's fixed price. We agreed to do that with NASA. And it's going to fly as an Air Force hosted payload. So all these collaboration, another way of thinking about NewSpace to how to get things in. And then finally, talking about modularity, standard, common interfaces. How do you get there? How do you make things faster? Well, you get faster by reusing things, tailoring them, adapting a different environment, taking this experience, applying it over here, taking this one that didn't work, turn it upside down, try it again. And we've convinced a lot of our customers to work in new ways and to consider different ways of contracting practices. How do you take advantage of something where Worldview, as an example, entire constellation of commercial fixed price, high res, high quality stuff? Why can't you do that on the defense side or at NASA? And we are starting to see many customers shifting that. And why? Because they don't have the money. So when you don't have the money and you have sequestration, you have the government shutting down, our government, who's a huge producer of and consumer of data, is really changing the way we think. Deep space, I got to come full circle, especially because I know we've had, some of you saw Ed Liu yesterday from B612 Foundation and the Sentinel mission that we're doing with them in a highly innovative, philanthropically funded telescope. And a lot of that technology comes from some of the breakthrough things that we're investing in. With DARPA, we worked in membrane optics material to take a transparent membrane with the diffractive optics etched into it that could change how the size and the mass and the power to get persistent real-time video of areas from Earth from GEO. And think about James Webb. We built those mirrors as well, and they are huge, and they are glass, and they are heavy. So something like this with a membrane that's almost like a saran wrap of how that could change how we get data from space in deep space. Kepler is at the bottom. We built that system as well, and at last count, I think we were over 4,600 potentially habitable planets, of which over 1,000 were confirmed that they really could be. That's huge innovation, and really thinking about how we do discovery from space and how we use data to do that. So the future I see as very integrated, bringing it back down to Earth. From our perspective, my personal one, certainly the one at Ball and many of you, it is about the consumer, the data that the consumer needs to make decisions every day. The farmer in the field who previously didn't even know that you could take pictures from space that would make a difference. I'll give an example of a project I worked on years ago, which was after the first Gulf War, and with the International Astronautical Federation and the Academy of Astronautics. So in Afghanistan, there was this highly entrepreneurial group who proposed to the UN, this was disaster relief, and they said, for $1 million, we will walk the ring road. So kind of like the Beltway in Washington, D.C. We'll walk the ring road, and we will tell you where the potholes are, where the roads have been blown out, because they were having trouble getting food and relief that was coming from international agencies to get food into the communities. And the watermelons were rotting because the trucks would try to drive, there's no road, and the watermelons rot, and then the people have no food. So they said, we'll walk it and we'll tell you. okay, we're in space. We're like, well, I think we have a picture of that already. You don't have to walk it, because this was going to take months to walk this whole thing. And you can use space. There's data. But how do you get it into the hands of the people who need it and translate that? We may know, but would we know how to get it to a developing country who needs this information to get the watermelons to the people? Not really. I think that's a great place where NewSpace can play, because we are thinking very innovatively. How do we take what we know from space, get it into the users who need it, and help translate that, help use the data analytics to transform. And we've heard lots of ideas the past couple of days about new data sources, new systems that can do just that. What are the platforms? Is it about the platform? Who cares? The farmer doesn't care how he got the data, just wants to be in the right expectation of what he or she could use. We see now the government making a lot of changes. Congress is talking more about commercial opportunities. Why should the government be the producer? Maybe they can just be the user. How do we change up our weather systems and our land imaging system? What about the new launchers who are, I'm so proud that so many, given my own background, to see the great enabler of access to space, lower cost, more frequent, which allows us to change up the infrastructures in order to deliver the kinds of things that we need to integrate. NGA, I would argue, who knows who NGA is? So a few. So NGA is the National Geospatial Intelligence Agency. It's the biggest consumer of geospatial data in our government from an intelligence side. They are changing. They are realizing that, well, hey, if we're going to be all these satellites in space, how can we take advantage? How can we use that better to know more about the Earth and share it with others? I encourage you, read the memo by the Deputy Director, Sue Gordon, that was published maybe about a month ago. It's a message to all the NGA employees, and it says, there's lots of flexible acquisition mechanisms, commercial ways of doing business. Take advantage of all this flexibility that we have. Use it in your day jobs. Do you know how long it took to get NASA to change and use a commercial approach for International Space Station cargo and crew resupply? In fact, that idea started back in 1999, actually when I was at Kistler. These things don't happen by magic. They take a long, long time. I think it was 11 years before the first contract was let to allow that. And NGA is like, well, hey, just do it. Let's just do it. It's there. And changing how the people are thinking. So we really understand how to do that at Ball. We understand the sensors, how to operate them, how to build them, going back and designing them first, and how to interpret what comes out on the other end. In fact, we have, as an example, a dozen meteorologists in our operations in Dayton, Ohio, and they are helping interpret data and data analytics that we have done with the Air Force and the intelligence community for decades. People wouldn't know that. So many things about transformation that you can see, who's not too big, not too small, but kind of just right, and we really understand that. But we can't do it alone either, and looking toward the future, looking toward the people who are making a difference, and partnerships and engagement. You know, one of the reasons we're really excited to be here today is to engage with all of you and partner where we can. We are actively engaged in a number of startups already. I mentioned Sentinel, Omni Earth, Tempest Global, Laserlight. In fact, Bob Brumley of Laserlight will be honored at tonight's gala. And a lot of our partners are really coming to us because it was mentioned yesterday with the investor panel about getting that credibility as well. You can have a great idea, but you have to be able to turn it into reality. And partnering can help do that, and working with somebody who understands kind of all those nuances, that agility to innovate and the strength to deliver. So as we think about NewSpace, we are all the future, and I'm so excited to see many many generations in this audience and being passionate and thinking about how we can bring things together to transform our world. We do a lot of collaboration. In fact, I've got some pictures in here from our summer intern program. They have a launch every year. Our interns develop the payload, and then the interns at United Launch Alliance build the rockets, and then together they do the launches. I think it's actually today in Colorado is this year's rocket things, and Chris was laughing. He said, "Did you plan these slides?" Because Andre in the bottom middle, he was his dorm mate at CU Boulder. I did not plan that. No, I should say I did plan that to show a picture. But we're very interested in investing in the future, being in the future. You know, Ball's been around for a long time. We intend to be around for a long time in the future. And with that, you know, I'll really want to thank the Space Foundation for the invitation to be here today. There's a lot of history there. Certainly Rick and Bob and Jim Muncie, who actually took a little look at my slides last night, which I really appreciate. We've been friends for a long time. Some of you met Gary Hudson last night, my former business partner at AirLaunch. Jeff, I think we came up with this idea walking around GeoInt a couple weeks ago, and certainly my team who's here today, I encourage you to meet with him and all the students. And really a shout out, I want to echo to the Space Foundation team who made this happen. Hannah, great job. Sarah, Molly, Audrey, Chris, the AV team. I'm sure there's many more I don't even know who build the environment for us to have this collaboration and this conversation. So all of you came before, all of you here today, those who will come after, thank you for what you do, and thank you for the future. And I think we all can give ourselves a round of applause for thinking about that and being here, being part of making a difference, and doing things that have never been done before. Thank you. So I'm happy to take any questions, and I know we have a little bit of a tight time frame, but I think two questions maybe. It's hard to see with the lights, and I think we have a mic if somebody has a question on both sides.
Thanks for being here this morning, Deborah. I was curious your take, having seen a number of things in the early days of the telecom constellation, ups and downs, what you're seeing now that you think is the same and what you're seeing now that you think is different in the way that's being approached?
That's a great question. I think a lot of it is timing. You know, in innovation, quite often, the ones with the original ideas is not the one in the end that sees it come to maturity. A big part of enabling the constellations, I think, was launch. And to change the architecture in space, you had to get there in a different way. In those early days with Globalstar and Iridium and Teledesic, really needed, for their business plan, had to take out a major chunk of money, and that was the space asset side. And I think today, we're seeing that. So not fully, but well on its way, and people then start to believe it, and once they start to believe it, you think it can happen. The other big disconnect back then was this disconnect with the consumer. I really believe one of the reasons that, take Iridium for example, which had huge success in launches, 66 spacecraft launched from 3 rockets from 3 different countries, including China, not one failure on the launch side, so hugely successful, but failed when it came to integrating with the consumer because the ground comm side came up with a little flip phone and said, whoa, if I can carry this in my pocket, I get information anywhere. It's not the same as having it everywhere, but close enough for what I need on a day-to-day basis. We didn't know how to sell to consumers in space. I don't know that we do yet either, but I think we have a greater appreciation about how to use stuff than we had back then.
Thank you.
Mm-hmm.
I have a question that the space technology is, can you forecast like tsunamis which has happened about 10 years back, or earthquake, recently earthquake happened in Himalayas, so it's a huge natural disaster. So can the space technologies forecast these type of natural disasters?
So that's a great question about predicting natural disasters. I believe that data, where we really want to go, is for the predictive analytics, to predict what's going to happen, not just being able to look behind. And that's another area, maybe get back to Erica's question, of different. Today we have so much more sophistication in where data can help data make decisions, find the trends, find the patterns, and look in history, and then apply with things that we know today and help with modeling and simulation, complex systems integration and system of systems. So I believe that that will be more possible. The thing that we don't know exactly from the Earth and the planet, which is another reason why I think we still need investment in Earth science, is to figure out, well, what is Mother Nature going to do? She might not be as predictable as people. But are there trends and patterns that if you take all that data that we've collected and see certain behavior and maybe indicators that could help us for the future?
Thank you for being here. My question is more in regards of investments. Is known you guys invest in such and participate in amazing missions, and we see the NSF and the government starting to divest from astronomy and from instrumentation and sites. Do you see any way that the industry can contribute into the maintaining these sites like Kitt Peak, Arecibo, Green Bank, that NASA and that NSF is divesting from, and it's only getting resources from NASA and hopefully the private industry?
Yeah, great. Another great question about continuing investment in astronomy and the facilities that go into that and the research that it enables. I do think a lot of advocacy continues to be necessary in those areas. We do see more private contributions into some of the telescopes and trying to take capability that perhaps the government had invested in and turn those over. A lot of work to do, and a key thing, I think, is changing the conversation a little bit about the results that we get and the information and why that's important. You know, we tend to segregate out of people traditionally think about, well, I need this satellite or this telescope to do just that, just one thing. And we are really trying to integrate a little bit more with opportunities, and I think everybody can be a citizen astronomer, citizen advocate, and help with that. I know we need to move on, so I want to thank you for your questions. Thank you for allowing me to be here. Have a great rest of the day.